I did not understand most of the introduction, but my name is Anton Olsen, and I work for a company called Innovation First. We do the VEX Robotics high school robotics competition, and we do Hexbug toys. Here's one of the toys, his little robot spider. These are the guys we'll be hacking later and turning them into actual robots instead of just toy robots. Okay, so the MSP430, as everybody who was here or in the previous session already knows, is Texas Instruments' inexpensive, what they call value line processor. The cost of these chips is around $1. They sell this development board for $4.30. My guess is it costs them about $10 to make it, so they're losing a little money. But they're getting people to use their chips and look at their chips and maybe put them in products later that, you know, sell hundreds of thousands of units. It's low power, so it's ideal for battery operations. Even when running, it uses very little power. Obviously, if you attach motors and LEDs, they'll draw a lot more power than the chip will. But if you need it to do something like go to sleep and wake up every hour and check temperature and then log that, this would be ideal, because when it goes to sleep, it will draw almost no current. This is the one we used in the last workshop. This is the MSG430, and the last three digits are the important one, the 231. And this is the one we used in the last workshop, and it's the ones we'll use in the next two workshops also. It's a smaller chip, so it fits on the breadboard. And I'll go ahead and pass this guy around, and you can look at him. Don't move the wires yet, though. That's what we'll be making in the second workshop on Thursday. Now that chip has a whole 2 kilobytes of flash memory. So your program has to fit inside of 2,000 bytes. And it has 128 bytes of RAM. So it's even more limiting than Twitter. You'd have to do some magic to get a full 140 character tweet out of that processor. Also supported by the Launchpad and some of the other chips or other development environments is the 452, which doubles the RAM and flash, and the 553, which doubles it again. All of these processors are very inexpensive. The difference in price between the cheapest one and the biggest one might be 30 cents. So this is what we did this morning. This is what we were going to do this afternoon. Quick introduction to the MSP430 programming. Okay, so we'll go on to Hexbug hacking. So this little guy runs off a remote. So what we're going to do with this guy is we're going to take and open up the remote control and hook wires between the remote control and the MSP430 Launchpad. If you want a closer look at the Launchpad. So we're gonna hook some wires up between that launch pad and the remote control for the spider, and essentially be able to control him from our computer. If you wanted to, you could write a serial routine from the computer, maybe to control the MSP430. I still need to work on the serial part, but at the very least, you'll be able to write programs for the MSP430 to poke the remote buttons and make the robot drive around. And then for the advanced one, we're going to build the spider that's going around now. And it's going to be a very abbreviated circuit. It's the bare minimum we can do to do motor controllers. Ideally, we would have to add more components to make it better, but this will work. Just show you how simple it is to interface two chips and how easy it is to make the Launchpad control a motor controller, which can start, stop, and change direction on DC motors. And I'm talking way too fast, aren't I? I meant to get a couple more slides in here for that part, but what's going to happen in this is we're going to use a set of photocells, and they will detect light. And if we have two photocells looking up at opposite directions, they can turn until they get the same amount of light, and then they know they're looking. So you shine a flashlight on it, it'll turn to you and then start walking. And that's going to be what we attempt to do in the last session on Thursday. The Launchpad gives you a lot of programming environments. These are only 3 of them. There's probably 6 or 7 robust ones out there, and a bunch of new ones that are just starting to show up. Most of them are based on other products, like the Energia is based on the Arduino environment. Most of them use the GCC compiler underneath it. So they're just giving you a fancy front end for the GCC compiler. Code Composer is free to use from TI. It does have limits, but none of the chips in this TI or in this value line exceed those limits. So I think you're allowed to compile a 16 KB code with the limited software, and that just happens to be the max of this line of processor. We'll be using Energia, which is a almost direct port of the Arduino software over to the MSP. They changed the back end to use MSP GCC, which is the GNU compiler. It does have bugs, but it does actually work for the most part. And just for another demonstration, this is the minimum circuit required, just to give you an idea of what it takes to make a program run. That's running a program that causes the LED to fade in and out. And it's using PWM to control that signal. So it can't lower the voltage, and LEDs don't like lower voltage anyway. So it gives it full voltage, turns it off, turns it back on, turns it off, turns it back on. And our eyes don't see that flicker, and they end up translating it to a dimmer light. Now, obviously, if you wanted to do anything useful, you have to add a button or something to make input or output or a sensor. But that's the bare minimum circuit to get a program to run and see that it's running. You could get rid of the LED and still see that, and it would still run. You just wouldn't have a way to notice. MSP features a bunch of different booster packs. I had hoped to have time to add a few more of these since I went over these already this morning. The one thing nice about these chips is they have the ability to do capacitive sensing, which is like a touch sensor. Your screen on your smartphone is a capacitive sensor. It's better than that. This will do like a 1-button capacitive sense. You'll notice a lot of modern electronics now have buttons on the face that you don't actually push, you just touch them. My new computer monitor at home doesn't have any buttons. They're just little LEDs on the face, and you touch the LED and it senses the capacity of your finger. This is my son's MP3 player right now. It's a Launchpad like we just passed around with an audio board strapped on top. It's got a little LCD that'll show you the MP3 that's playing, and a kind of a wheel like the old iPods used to have for controlling the MP3 player. It works well, and you can put any sized SD card in it you want. The software is a little clunky, but I'm challenging him to write something better, maybe with a bigger LCD. LED matrices you can use for making games. You could use for displaying information. I did one with this particular matrix at the office that scrolls a number by, and that number is roughly the health of our web servers at the office. So just by having this little display hanging on my wall, I can get a rough idea of how good our servers are doing, or if they're starting to melt down and I need to go tend to them a little bit. So it's actually become a real world alarm. The mini booster, I just recently got one of these. I have not had time to use it yet. You could use this to do things like physical computing, like Frenchie's going to talk about later, if he hasn't already. Putting sensors on your body, putting sensors on the floor or in the room, and reading them with a microcontroller, and then sending signals based on that back to a MIDI output device, like a keyboard or maybe Ableton running on your computer. And you could actually come up with, some ideas, walk through a room and you kind of hear some music follow you, and based on your position in the room, do a stereo fade. And this little LCD booster should be at my house today or tomorrow. They didn't ship it in time to get here. This is a fun little, I think that's exactly the same screen that was on the Game Boy. Anybody here know what a Game Boy is? Not the Game Boy Advance. Not the Nintendo DS, but way back, probably about the time most of you were born. When were most of you born? About 90s? So before most of you were born. But we could go back and do some 8-bit retro gaming with some monochrome LCD. At Maker Faire, a guy had one of these set up, and he had like a temple run game that you play. It was this and one button was the game. When you died, it reset and you started over. And all you had to do was hit the button to jump. and you had to hold the button to duck, I think is how it worked. So if you tapped the button, you jump. If you held the button, you duck. And you had to go up and down and over and through, and just like Temple Run on the iPhone, only a lot smaller. Okay. Does anybody have any questions? I had to cut out about a bunch of my slides I was going to talk about because we used them earlier. But anybody have any questions about the MSP? Yeah. Sure. Those are the photocells. These sense light, and they change resistance. So the more light there is, the lower their resistance. So they're like a variable resistor. They're for the robot will check those with an analog input to see what the voltage is and measure the voltage. And whichever voltage is higher has more light. And it'll turn in that direction. So the software looks at those, takes a reading from the left one, takes a reading from the right one, compares them and decides whether it needs to turn or whether it should start driving. Any other questions or ideas on what could be done with these robots? This guy's not going to fetch a soda for you. The robot is, I think they retail for $25 in the United States. I don't know what they cost down here. Radio Shack might sell them if you have those in the area. But the brain on top, that's about $4 or $5 worth of parts. So relatively cheap. And you could control any other toy. If you can find a toy with 2 motors, that same circuit could be designed or changed up to drive just about any toy with 2 motors. So if you can find a little car that has, like tank drive, one motor for one wheel, one motor for the other side, you could control it with that. Could probably control a remote control car, but sensing what direction you're currently pointing, and you could control the motor that steers, but knowing that you're going straight would be tricky. You'd have to add a sensor to pull that in. Yes.
So we have to focus on this.
Yes.
We suppose the other one. If we have more light here,
Yeah.
we will go in the direction.
Yep. So if somebody shines a light on me here, I will turn until I see that I'm looking at the light and both eyes have the same light. And then I'll start walking towards the light. We could make him run away from the light too if we wanted to. Just change the less than to an equals or to a greater than, and we would change that behavior. So he would go anywhere dark. As soon as he turned far enough that he wasn't looking directly at the light or near the light, then he would start walking away.
So we can follow the light or dark.
You could do either, yes. Dark's bigger though, because if you get a light source, he's going to walk towards me. If you're looking for the dark, he's going to walk anywhere but towards me. So he could be walking that way instead of straight away. Or you could put the light sensor on his tail, and then he will walk straight away from you. There's
about the Launchpad, is it only to program chips, or does it do anything by itself?
You can use it by itself and wire things up to it. It's a full development environment. So if you want to, in our case for this one, we're using it to program the chip. But in the middle class where we're doing the remote control, we'll actually hook the wires from the Launchpad directly to the remote control on the robot, and we'll leave the chip in the Launchpad. And you can also just hook power up to the Launchpad once you program the chip. Take it away from the computer, remove the USB cable, and just hook power up directly to the Launchpad and go from there. So you can put it in a box, power it with a battery, and still keep it in the Launchpad circuit board. Anything else? Or thank you. Now, one of the other toys I have at home is called. Hello, there it is. It's called a Big Track, and this was a very popular toy in the late '70s. It had a numeric keypad on top and some directional arrows, and you would like hit program, and you go forward, 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 right, right, back, back, left, left, and play. And he would do all those things. And recently, a company introduced a mini version of that, which is about half the size. Does everything the same, except they did it on a teeny tiny microprocessor. The original one used a board about this big inside there. And we've taken that at home and we've ripped the guts out of that and put a Launchpad in its place. And it drives around the house using a pair of optical sensors to avoid obstacles and terrorizes the cats. I will share this information with Oscar later as far as links and stuff for all the MSP430 information. The TI Launchpad Wiki is probably the best starting point for information. That's where all the official news, where all the engineering notes and documents and data sheets for the chips are. CSS for Launchpad, if you want to get down and dirty and actually program at the low level of C at least. That's a good place to start. MSPGCC, if you're a masochist and you like to be punished a lot, then I would suggest going that route. You're going to have a lot more control over your code, but you're going to need to write everything yourself. There's no libraries. There's no, oh, I want to analog out this pin and make an LED fade. You're going to have to write all that yourself. It's not difficult, and once you get the hang of it, it's actually fairly simple code. But it does take, it does have a learning curve that higher level ones like Inertia kind of take all that work out of there for you. The other place to look, and see if I can get a browser to come up here. You would have to put that in the Launchpad to program it with Inertia. That's why I left the pins long. Yeah, the Launchpad in that case is just used to program the chip, and it can then be removed. We could also remove the chip and put it in our own circuit board. Like maybe we designed a smaller, cheaper circuit board for a robot controller, and we could pull that out. The other way is there are pins that you can program it in circuit. You can program with the MSP when it's in the circuit. There are 5 pins that you would need to connect to a connector out to something like the Launchpad. And then you could easily just leave it in your robot and program it with a serial cable or something to that effect. This site, 430. And O is kind of a play on the English 0 and O and an exclamation of surprise. This is a hobbyist site that was started, it was originally started by some TI engineers who thought they needed at least something for the hobbies community. There are hundreds of projects on here using the Launchpad, using the different chips, discussions about which chip is better for which task, and how to get around some of the limitations of the chips. And I highly recommend this if you're interested in using the MSP430, that you check out this site. They have a ton of tutorials, probably 40 or 50 tutorials you could go through. If you went through them, you would know just about everything you need to know to program at a good mid to high level. You wouldn't be an expert microcontroller programmer, but you would know enough to become one. Okay, thank you very much.